Hello everyone, welcome again. Myself Sujit Sari, lecturer in Mechanical Engineering Department, Jain Polytechnic, Pelgam. So today we'll go through third chapter, that is thermodynamic cycle from the subject basic thermal engineering. So in this video, we'll be learning that is what do you mean by an introduction. Okay, introduction to the thermodynamic cycle. Then we'll see reversible and irreversible cycles, and then we'll go to assumptions. Okay, assumptions made in the air standard cycle, and then finally we'll learn about what are the different types of cycle, that is Carnot cycle, Otto cycle, diesel cycle, and dual cycle. So this video will be made in 2 to 3 parts. So first we'll go through what do you mean by introduction, reversible, and assumptions. Clear? So let's see introduction. Okay, introduction to thermodynamic cycle. So a thermodynamic cycle is a series of thermodynamic processes which returns a system to its initial state. In the sense, on the right side you can see there is a PV diagram. So consider you have these two, there are four processes. Okay, so 1 to 2 is one process, 2 to 3 is another, 3 to 4 is another process, 4 to 1 is another process. So all these processes are reversible. So in the sense, whenever the system undergoes a change, that is from one state to another state, so 1 2 3 4 we call them as individual states. So reversible process is nothing but when a system undergoes a change from one to another, it can be reversed such that it again reaches its initial position. Okay, so all such reversible processes are combined to form a reversible cycle, what we call it as a thermodynamic cycle. So that is what the explanation of thermodynamic cycle. The properties depend only on the thermodynamic state and thus does not change over a cycle. So if you consider the properties of system, they are nothing but temperature, pressure, and volume. So those properties depend only on the thermodynamic state, that is these states 1, 2, 3, and 4, and they do not change over a cycle. So variables such as heat and work are not zero over a cycle. In the sense, there will be some heat and work produced on each process during each process, and these are not zero when you consider a whole cycle. Clear, guys? Okay. So next we'll go to what do you mean by reversible and irreversible cycle. So first we'll start with reversible cycle. A reversible cycle is one in which the initial and final state of a cycle are same. In the sense, here for example a system starts its what do you call the process from point 1, that is from state 1, then it reaches state 2, state 3, state 4, and finally again it reaches back to state 1. So that we call it as a reversible cycle, means its initial position and final position are same. So it means both system and surroundings are returned to its initial state at the end of the cycle. So when you say at the end of the cycle, so its initial state and final state are same. So reversible processes are combined to form a reversible cycle. So like I said earlier in the previous slide, okay, so that the various reversible processes are attached so that it forms a reversible cycle. So now next let's go to irreversible cycle. So irreversible cycle, same way, it is just opposite of reversible. An irreversible cycle is one in which the initial state and final state are not same. In the sense, if you consider that initial state, okay, there is some initial state, and then a process takes place, and there will be a final state. So in irreversible, the initial and final state are totally different; they are not same. So it means the system are not returned to its initial state condition at the end of the cycle. So when you consider irreversible cycle, so at the end of that cycle, so initial state will be different and final state will be different. They are not same, which is the case of reversible cycle. In reversible cycle, what happens? The initial and final state are same, and the initial condition and final condition at the end of the cycle, they are both same. So in irreversible, they are not same. So now next, let's go to what do you mean by the assumptions made in air standard cycle. So first one we'll see the gas in the engine cylinder is a perfect gas, that it obeys the gas laws. So what are the gas laws? So there are various gas laws, what we call them as Boyle's laws and Charles law. So whatever the gas we are using for the experiment, that is these various cycles. So whatever the gas we use there, so it all the gas or whatever the air is there, it obeys all the gas laws. So next, the compression and expansion processes are adiabatic. So now in a process, for example, if you consider some cycle, so during that cycle there will be various processes. So it may be a compression process, it may be an expansion process. So during compression and expansion process, these two processes are, we call them as adiabatic, means During this process, no heat is added or removed from the system. Next, there is no friction between the moving parts. So for example, if you consider a piston and cylinder arrangement, so the inside wall of the cylinder and the piston. So when the piston is moving inside of that cylinder, there will be some friction. So in this assumption, for this air standard cycle, it is assumed that there is no friction between the moving parts. So no chemical reaction takes place inside the cylinder. So now for example, there is a piston cylinder arrangement, and just below that piston you have a gas. So to that gas we provide the heat so that expansion takes place. Okay. So to that expansion, whenever the heat is supplied to that gas, there is no chemical reaction taking place inside that cylinder. So that is the assumption. So next, fifth one, heat is supplied or rejected by bringing the hot body and cold body in contact with the cylinder. In the sense, there will be two bodies, separate bodies, a hot body and cold body. So when you want to supply a heat, hot body is brought closer to the cylinder, and when you want to remove the heat from the gas, cold body is brought in contact with the cylinder. Okay, so these are the assumptions which are used during finding the air standard cycle efficiency. Okay, during the explanation of those, these are the assumptions that are made. So next we'll see some important concept regarding the what you call the PV diagram. Okay, so it just come to know what is this important concept. So it's in the cyclic process. So if the cyclic process moves clockwise around the loop, then it represents the heat engine. Okay, for example, you consider this PV diagram. During this process, for example, now if you consider if a cyclic process moves clockwise around the loop, then it represents the heat engine. For example, now consider this, you have a graph here, PV diagram. So here four processes are combined to form a cycle. So if you can see, the direction of the cycle is in what? Clockwise direction. So if there is a PV diagram, and if there is a cycle which is moving in clockwise direction, then it is represented as a heat engine. So the best example of your heat engine is nothing but your petrol or diesel engine. Okay, why we call them as heat engine? Because whatever the heat is supplied to the gas, for example we consider gas, when we supply heat to the gas expands. So how, what it does, it moves the piston. So during that process what happens, the work is done by the gas onto the piston. So when work is done by the gas onto the piston, work done is positive. Okay, so that work done is positive is in the case of your heat engines. Okay, so when you see a cycle which is in clockwise direction, we call it as a heat engine. Similarly, when the same cycle is in anti-clockwise direction, if it is moving in anti-clockwise direction, we call it as a heat pump. So best example of your heat pump is nothing but your air conditioning. Okay, so what that air conditioning does is it absorbs all the hot air from the room and it supplies the cold air. Means the work is done on the gas by the system, sorry, by the external what you call work doing mechanisms. Okay, so work is done on the gas, so that's why the work done will be negative. Okay, so when you get whatever your cycle will be, a cycle will be in terms of what, anti-clockwise direction, so it represents a heat pump. Clear guys? So now for this chapter, okay, basically we'll be using the heat engine cycle, that is a cycle rotating in clockwise direction. Clear? So the efficiency of the engine using air as the working medium is known as air standard efficiency. So we'll be learning various efficiencies, that is Otto cycle, Carnot, diesel, dual cycle. So we'll be finding what is the efficiency of those cycles. Clear guys? So this is the basic introduction to the third chapter, that is thermodynamic cycle. So in next chapter we'll see, in next videos we'll see various types of cycles. Thank you.